All right, so on the Earth then, let's continue with our history of the atmosphere. And where I want to pick up in this story is around 650 million years ago. We had what's called the last snowball Earth phase. So the Earth froze over. In this situation, we believe it's because most of the continental land masses were in approximately the same position. And so all of the land masses were together. And that made it more difficult to distribute heat to the interiors of the land masses and affected ocean circulation. And there could be other contributing factors as well. But essentially, the Earth froze over. Okay? And so once the Earth froze, then we had ice on the surface. And that means no evaporation, no rain, and that means no conversion of CO2 to rock. So this is the other side of the story, because this is actually good. This shuts down the reactions of carbon dioxide with calcium that control the carbon dioxide levels. You don't want to control them if the Earth is frozen over. Okay? And so if the Earth didn't have heat in its interior, if the Earth's interior was dead at that point, then we wouldn't have any more carbon dioxide gas being produced in volcanoes, and the Earth would have stayed frozen. Okay? But it didn't stay frozen because of the volcanic eruptions. This is just on the surface that it's frozen. The interior is still very warm. And so it actually produced way more CO2 gas than the Earth's atmosphere would normally have. And this melted the ice. But then the CO2 levels were too high. And so this produced heating. But the heating produced more evaporation. And more CO2 removal. Until the CO2 levels were too low. And then we got cooling again. And so this process continued over and over again, going between cooling and heating. But during each cycle, the cooling and the heating processes were a little less severe. So this would be 650 million years ago. This would be about 550 million years ago. So the temperature would go way down. This would be snowball Earth. And then it would go way high. It would be too hot. But that would kick in the evaporation that would melt the ice. That would pull way too much carbon dioxide out of the atmosphere. And then it would get cold again. But not as cold as before. Then it would go up. It would overshoot, but it wouldn't get as hot as before. And eventually, these cycles died out, and we went back to normal temperature. So this process then of the thermostat mechanism kind of oscillating back and forth between too hot and too cold, we believe took something like 100 million years. And some people think this could be a credible coincidence, but other people think that this is the cause of what's called the Cambrian explosion. We had this explosion of life. So multicelled life began during this heating and cooling process and started to proliferate. And so multicelled life, this is basically this torture test for the Earth's fluctuations in the Earth's temperature, we believe are what gave rise to the mutations, the best possible adaptations to these severe conditions, and limited numbers of populations of different creatures gave rise to a superior genetic structure for the survivors. And those survivors then started all of the forms of life that we see on the Earth today. So complex life begins, and it began because of fluctuations in the Earth's climate. And so you can see how the processes of the Earth's thermostat mechanism have given rise to life on the planet, and life on the planet in turn affects the atmosphere, which then in turn affects life, and so they mutually interact with each other as a single system. And this is why I'm talking about this in a meteorology class, because you can't really separate the geology and the meteorology from the life. It's all part of the same story. Okay? And so as time went on then, plant life started to diversify, and then plants went on to land. Followed by the animals. Today, we believe about half of the atmospheric oxygen is produced by land plants and about half by photosynthesis in the oceans. Then, as time progresses, about 300 million years ago, oxygen levels reached their peak. Somewhere around 27% of the Earth's atmosphere. Recall that in today's Earth, the oxygen is more like 20%. And so this is much higher amount of oxygen. And in those times you had gigantic plants and insects. Called the Carboniferous era. And we had dragonflies in those days that were like 5 feet long. And they were able to absorb oxygen right through their skin because there was so much oxygen. You didn't need a well-developed lung system. You could have very big creatures that were like insects, that didn't have sophisticated internal organs that could just diffuse oxygen through. And so much of our oil deposits and things come from decayed plant matter and animal life from this Carboniferous era about 300 million years ago. Now, this eventually gave rise to one of the biggest mass extinction events in the Earth's history, 250 million years ago. Coal in Siberia that was accumulated from the Carboniferous era was vaporized by volcanic eruptions. Sometimes called the Siberian traps. And this released so much polluting coal vapor and particulate matter into the atmosphere that it triggered a series of chain reactions. And the result of all of this is what's called the biggest mass extinction event in the history of the Earth. Believed that there was something like a 5-degree rise in temperature, and that rise in temperature caused frozen methane ice in the oceans to vaporize. And by the way, this can happen again today because there's still a lot of methane ice in the Earth's, the bottom of the Earth's oceans. But this triggered methane ice evaporation, which then triggered another 5-degree rise. For a total of 10 degrees average temperature, rise in temperature. And so all of this then eventually caused all the fish to die in the oceans. And something like 99.9% of all life on the lands and the oceans died. And so this is perhaps the most extreme example of how global climate change can adversely affect the well-being of all of the life on our planet. And so as we look today at some of the changes, some of which may be brought about by our technology as we pump more and more carbon dioxide into the atmosphere, we can look at this and see that, well, maybe this is more than just, oh, it's a nice hot day, let's pull out the jet ski and go out and have a fun day. This could give rise to catastrophic events like the evaporation of our oceans, or big enough temperature rises globally to cause almost all of the life on the planet to be exterminated. And so this event then, the most significant mass extinction event, which is caused by uncontrolled global warming, is called the Permian extinction.